So what other x's should we be choosing to substitute in? Now that we know where the vertex is, what are the other x's? 1 and 2, because those come before 3, and 4 and 5. So we're going to take each one of those x's and we're going to do just like what we did on Friday, where we substitute it into that quadratic function to find what the y value, what the output is. Yep, you're going to graph both of them on the same graph, not on two different graphs. Yes, sir. Pencil, absolutely. You're welcome. If we put 1 in the place of x, first thing I need to do is square it. What's 1 squared? 1. And then I'm going to do 6 times 1. 6. So I do 1 minus 6. What's 1 minus 6?
5.
Positive or negative?
Negative.
Negative 5 plus 9. Positive 4. So that means I have a point at 1, 4, because when we put 1 in, we got 4 back. So 1, 4. I put this in the wrong spot. That's supposed to be at 3, 0, not 0, 3. And then I put 2 in. We're going to square the 2. What's 2 squared?
4.
4. What's 6 times 4?
24.
24. Or sorry, we're putting 2 in, my bad. So I have 4 minus 6 times 2. 12. 4 minus 12.
Negative 8.
Negative 8 plus 9. So when we put 2 in, we get 1 back as our output. So I have an ordered pair at 2, 1. So we're going to put 4 in now. What should we see happen? Yeah, we should end up with some repeats of these y values because it should be symmetric on the other side of the vertex. We went through the difficulties of finding our vertex here. So first I do 4 squared. What's 4 squared?
16.
16 minus 6 times 4. There's the 24. What's 16 minus 24? Negative 8 plus 9. 1. There's the first repeated value that we expected to see. So we have an ordered pair of 4, 1. Yep, 5 is going to have an output of 4. We can double check that by substituting in, right? It'd be 25 minus 30 plus 9. So we get 4 as our output. The x side you put in for the x's in both spots. Yep.
What do you mean?
Well, there's 2 places here for x. It goes, yeah. All right, so I'm going to sketch in my parabola now. And what do we still need to graph? We need to graph our linear equation.
This is a straight line from point 2, 1, and 5, 4.
All right. What is this thing in slope-intercept form? Yep, 1 plus x equals y. I'm going to add x to both sides because I want this in slope-intercept form if I'm going to graph it. Y equals, it would be x minus 1, right? Yep. So here's slope-intercept form. My y-intercept is 0, negative 1. And my slope is what? 1 over 1, rise over run. So starting from -1, I'm going to go up 1 and right 1, up 1 and right 1, until I can't do that anymore. How many places does it cross the parabola? Twice. At 2, 1 and at 5, 4. You're absolutely correct. So those would be my solutions. Right here and right here. We are going to verify that algebraically. So I'm going to make some room up at the top so that I can do that. What do I want to do if I'm going to solve this algebraically? I want to set them equal to each other. I need them both in y equals form to set them equal to each other. So I'm going to do this slope-intercept form right here. So I'm going to have x minus 1, and that gets set equal to my quadratic right here. X squared minus 6x plus 9. Because it's a quadratic equation, if I'm going to find what x is, what do I need this equal to? 0. Whenever you see this, and we're doing it algebraically, I don't care what algebraic method you're using, factoring, completing the square, quadratic formula, it has to be equal to 0.
So u minus x equals 1.
Yes. I'm going to minus the x, and I'm going to plus the 1. So I get 0 equals x squared minus what?
7x.
Yep. Minus 7x plus 10. And now we're going to need to factor this. Or you could do what? We could do quadratic formula. We could do the completing the square thing and solve that way. If it's in standard form, I think it's easier to do either factoring or quadratic formula. Because we graphed it and we saw that these solutions end up on whole numbers, I know for a fact that this will factor. If I graphed it and I couldn't tell exactly where they were crossing, quadratic formula might be a better way to go about it. Okay? If at least one of these comes out to be a whole number, the whole thing has to factor. Because remember, not every quadratic equation will factor. I multiply a and c together. What is a times c? 10. Down on the bottom, it needs to add to my b term. What's our b term? -7. What multiplies to 10?
5 and 2.
5 and 2, but I want it to add to -7.
-5.
-5, -2. And then I'm going to do my area model. I know I don't have a lot of room for this. I have x squared here, 10 here. It does not matter where I put the -5 and where I put the -2. Yes, ma'am.
How do we know which one gets the sign, like for -5 and 2? Like which one gets the negative sign?
So if your b term is negative, the bigger number has to be negative. And then from there, I make sure that it's going to multiply to give me the correct sign. So if this is negative, the bigger one has to be negative. And then if I'm multiplying these two together and it's coming out to give me a positive, they have to have the same sign.
So then you substitute it back into find y?
Mm-hmm. So -2x, -5x. What's the only thing I can take out of x squared and -5x?
X minus 5.
Yep. I'm going to have x here. This direction I can take out a -2. But the other direction, you're right, I can take out a negative 5. X minus 5, x minus 2. What do we do with each of those? Set them equal to 0. X minus 2 equals 0. X minus 5 equals 0. We get 2 and 5, but that still doesn't give me the y parts of the ordered pairs.
So you need to put it in for y.
We need to put it in for y. Does it matter which equation we stick it in to get y?
No.
Nope. Which one is probably easier, though?
The first one.
Yeah. I'd put it in here, and I'd put it in my slope-intercept form of it. So I would have y equals 2 minus 1. Y equals 1. So when I used 2 as my input, I got 1 as my output. So the solution is 2, 1. Over here, we're going to put 5 in the place of the x. So 5 minus 1. 5 minus 1 is? 4. So when I used 5 as my input, 4 was my output. So the ordered pair 4, 5.
Where did you get the 1?
Right here. We're substituting into this. We could substitute into this. That would be fine also. You have to pick one of these to find the y part of the ordered pair.
You switched them.
Oh, thank you. You're right. 5 was the input. 4 was the output. Thank you, ladies. All right. I want you guys to try the next one on your own. So I want you to do number 3 by graphing and solving algebraically. So much all over the screen right there.
Use one of the graphs, we just put on 111 for another curve.
Yeah, use one of those graphs, yes.
We need to order for that. I would do it.
I thought you were talking about the shoes.
Please make sure you're practicing this along with us because this will be a question on the test. Graph it, and you want to solve it algebraically. Find your vertex. Take a couple points on either side of the vertex so that you can get graphed. If it's not already in y equals form, put them in y equals form. You'll find your vertex by doing negative b over 2a. The other one you want it in slope. You need a y equals equation. Yep. Minus 2x squared, you can do that. Yes, you can do that.
Have you got lessons?
Yes. Here you have a times c. What's your a value? Yep. form first.
Mark is airball.
So what's wrong?
For your quadratic, which one is your quadratic?
So
Because negative b over 2a finds the axis of symmetry. Lines don't have symmetry.
it's standard in a
Yeah,
squared.
that's what
B
that's
squared.
good, wasn't it?
I mean, a squared plus b.
ax squared plus bx plus c.
I want to know about making this control y equals.
So you need to get the y on the side by itself.
Was that where that picture was from? That one was from.
You can add 2 to both sides. That's going to set it equal to 0, and that's fine.
Yeah.
Plus 3x.
2 plus 3x minus 1. If you add y to both sides, now you have the y all alone, and it's positive.
I want to go with it. Ready? No, I can't put it.
I am. You ain't gonna make it though. Why you asking? You never did. You ain't
So it would be 2 plus 3x. Plus 0 equals y.
You don't have to have the plus 0, but yes.
So this equals y.
Mhm. Right.
Then my other one, is that the one I should be putting x equals negative b over 2a?
You need to get it in a y equals form also first.
So x equals, that would be positive y?
Yep.
B?
2x squared. Oh, well, you got to get it in y equals form first. Yep, get it in y equals form. Mhm.
Okay,
So now we're going to do the
This.
negative b over 2a. Yes.
so okay, so this is our a value, or b is 0.
Mhm.
You can have a negative 0.
Correct, but that would just be a 0.
Yeah.
Mhm.
Okay. And that gives you your vertex?
That gives you your axis of symmetry. That gives you the x part of the vertex. To find the y part, you just plug it in, and that's what we do with all the other x's anyway.
What do you mean you just put it into the y?
You put it in for the x's.
And it, okay.
Mhm.
No, I'm talking about this one, 2x squared. I'm trying to find the vertex.
Later bills.
Mhm.
That's the only thing I didn't think that was right.
Yep, that is correct. Yeah, if you subtracted the 2x squared from both sides, then you just divide by -1. You end up in the same place as if you add y. Yep, comes out to be exactly the same.
What's my b though? Miss Bo, what's my b?
What's your a value? 2. Where is your b value?
Why you touching my box?
If you don't see it, what would the value for b?
1
No?
or
0. Mhm. If it's totally missing, it's a 0. Yes, sir.
Y equals Amazon dropping the very last.
Okay, so you have those both as negative y equals. How do you get rid of the negative out in front? Mm-hmm. Yes, sir.
How do we get the vertex in?
So you need to get it in y equals form,
Yeah, alright.
and then you do negative b over 2a
Mm-hmm.
to get the x part of the vertex. Yes, ma'am. So you want it to multiply to 20. What's in front of your 20 here?
everybody has
So that
that.
needs to be here also. Same thing with your 1. But then, yes, you want it to multiply to give you negative 20 and add to give you negative 1.
Background, somebody picture.
Bro.
So if we're going to graph these, I need them both in y equals form. Is the top one a line or a parabola?
It's a parabola. No, the top one's a line.
Top one's a line. How do you know when you look at it that it's a line?
If it has a square root, the square root.
Yeah. Does it have the squared or not? It doesn't have anything that's squared. So this is going to be a line. I need the y all alone. How do I get the y alone?
You subtract the x squared.
There's no x squared here.
I'm sorry, there's x. Oh, the line where I didn't do that one. Sorry. I didn't do that one.
I can subtract 3x from both sides. I could also choose to add y to both sides.
Wait, so why didn't you do this one first? You just chose it first?
It's on top.
Oh, okay.
That's as deep as my thinking went. If I subtract 3x from both sides, that negative is still in front of my y. So I have to divide everything by negative 1. Or you could multiply by negative 1. It has the same result. So what is this in y equals form? Y equals 3x plus 2. So this is the line that we're going to graph. Where's my y-intercept? 0, 2. And what's my slope? 3 over 1. Rise over run. So I start at 2, and I'm going to go up 1, 2, 3, and to the right 1. 1, 2, 3, and to the right 1. And I'm going to go backwards. 1, 2, 3 to the left 1. 1, 2, 3 to the left 1. Here and here. And I'm going to draw my line in. So far, so good? All right. Let's talk about the parabola. How do we know this one is a parabola again? Yep. It has a squared in it. So this is my parabola. Is it in y equals form? How do I get it in y equals form? Add y to both sides. Yep. Y equals 2x squared. If I'm adding 0 to something, it's the same as not even being there, so I don't have to worry about the 0. And then to find my axis of symmetry, that's the x part of the vertex, we do x equals negative b over 2a. What is our b value? 0. Over 2a, what's our a value? 2. So I end up with 0 over 4. What's 0 over 4? Just 0. So when I go to make my table so that I can get a couple of points on here, 0 goes here. I want to pick some x's that come before it and some x's that come after it. What comes before 0? Negative 1, negative 2, and then I need a couple that come after it, so positive 1, positive 2. Let's see what we get when we substitute in. I'm going to take 0 first, my vertex, and substitute it into the y equals for my parabola. Do I multiply by 2 first, or do I square it first? What does order of operations say? Square it first. What's 0 squared?
0.
Times 2? 0. So I have an ordered pair at 0, 0. Thank you, ma'am. Let's do the same thing with negative 1. You said I square it first, right? What's negative 1 times itself? 1 times 2? So I have an ordered pair at negative 1, 2. I'm going to take negative 2 and put it in the place of x. What is negative 2 times itself?
4.
4 times 2? 8. So I have an ordered pair at negative 2, 8. What happens when I do the same operations but with the positives?
You have the same answers.
I get the same output. So it's going to be 1, 2, and 2, 8. And then I'm going to trace in this parabola here. How many times does it cross my line? Twice. Once right here, that's easy for me to see. There's a solution. Where's that ordered pair at?
2, 8.
2, 8. The other solution is right here, but I don't know what that ordered pair is because that's not crossing nicely, right? So I'm going to have to use an algebraic method to determine exactly where that is. We said we were supposed to check this algebraically anyway. How do I set this up to do it algebraically? Set them equal to each other. From which form? Yep, from our y equals form. So yeah, we're going to do the slope-intercept form right here, and we're going to do the standard form right here. So I'm going to have 2x squared. That's my standard form. It gets set equal to what? 3x plus 2. I want both of them in the y equals forms, and then I set them equal. This is quadratic, right? Which means I need to do what with it? Set it equal to 0. So I'm going to subtract 3x from both sides, and I'm going to subtract 2 from both sides. So 2x squared minus 3x minus 2 equals 0. And we're going to factor this guy. So I'm going to need my x. We have to multiply a and c together. What am I multiplying together up here? Yep, 2 and negative 2. So I need two numbers that multiply to give me negative 4, but when I take those same two numbers and add them, I get what? Negative 3. What multiplies to negative 4 but adds to negative 3?
Negative 4, positive 1.
Negative 4 and positive 1. I'm going to draw my area model now. I'm making it really long because I can't make it very tall. Right? It just gets really skinny. All right, so I have 2x squared here. I have negative 2 here. I have negative 4x, and I have a positive 1x. What can I take out of both 2 and 4?
2x.
2, so I can take a 2x out this way. What about 1 and negative 2?
1.
I can take a 1 out. Positive or negative?
Positive.
Positive. So 2x plus 1. That's one of my factors that I'm going to set equal to 0. What can I take out of 2 and 1?
1.
Just 1. So I can take a 1x out this way. What can I take out of 4 and 2?
2. Negative 2.
2. And it's touching a negative, so it's a negative 2. So x minus 2 is the other one. All right. Let's do this one first. Not only is it easier, I'm pretty sure I know where that one is. Does anybody know why I knew this would factor?
Because we found a solution.
We found a solution and it had a whole number, right? So I knew it was going to factor. So I'm going to add 2 to both sides. X equals 2. How do I check to make sure that the y part of the ordered pair is correct?
Substitute it back in.
Substitute it back in into either one of these equations. Are you guys okay if we sub it into the line?
Yep.
All right. So I would have y equals 3 times 2 plus 2. What's 3 times 2?
6.
6 plus 2, 8. So when we put 2 in, We got 8 as the output.
So what if you, for the other one though?
Let's go do the other one right now. I did that one because I knew where that one was already. This one, what do I need to do to get the x by itself here? Subtract 1 and then divide by 2. So I end up with negative 1/2 or negative 0.5. Mm-hmm. So I have negative 1/2 or negative 0.5.
Oh,
And then we substitute that in. So I have 3 times negative 0.5
oh, it's a solution for anywhere it crosses that?
plus 2. We need solutions for everywhere it's crossing, everywhere the line is crossing the parabola. What do you get when you do 3 times negative 0.5?
Negative, I mean 0.5.
Yep. You get negative 1.5 or negative 1.5. And then plus 2, we get 0.5. So this ordered pair, I absolutely ran out of room to do it. Negative 1/2, positive 1/2. Or you can write it in its decimal form of negative 0.5, 0.5. That would be our other solution. All right. That's where we're going to stop. I'm going to pass out your reviews for the test. Test is this Thursday. We've covered everything that we need to solving-wise. We've covered 3 different algebraic methods. We've covered solving by graphing. And we've talked about when we're not finding the x-intercepts, when we instead want to find where a parabola crosses a line, so nonlinear systems.
It's so sad because my grandma accidentally left the door open